Good morning, students. I hope you all are good and enjoying your time. Students, let's continue the remaining questions of the midterm paper December 2022 in BMI. So, the question number 7, we are going to start from here. Question number 7. For this, it was given to you that in a rectangle with sides of length x centimeter and width y centimeter, where x is bigger than y. So you are given a rectangular field. Here is this side is a river. This is a diagram given to you. And x is bigger than y. So it means this will be, if x, it will be y and y. Here we have three side fence around the rectangular field. Three sides of the rectangle are being fenced with the wire of 24 centimeter. It means the perimeter of the wire starting from here to this to this. This is how much? 24 centimeters. Means perimeter of this. So in short, I can say that x plus y makes 2y equal to 24 centimeter. This is given. And we have to show that the area of this rectangle is 12 minus 1 by 2 x square. We have to show this thing. Okay, let's see how. You are given only this thing, and we know the area of rectangle. Area of rectangle is x with length and breadth x times y. We know 1/9, and the second according to the question. We need to simplify them. From 1, we can make any variable as a subjective formula. Let's take y from here, because in result we need only x. So make y, because you can see in area result we have only x variable. So make y subjective formula from 1. So we will write 24 minus x whole divided by 2. Now do replace this value of y in equation number 2. So we'll get a equal to x times y. Y is what? 24 minus x by 2. So after simplifying, we get area is equal to 24x minus x square whole divided by 2. We can divide it independently. So 12x minus 1 by 2 x square. When you divide this with 24 by applying the property a minus b over c, distribute this like this. So this is the what we have to prove. So here we can say proved, hence it has been proved. The area of this three-sided fence rectangular field is 12x minus 1 by 2 x square. Proved. Now further, they also asked in the question, do find domain and range of this function area. So we know that area cannot never be negative in measures. It's always be positive, because square unit. So we can say as a is bigger than 0, so implies that this whole result 12x minus 1 by 2 x square, take this 0 for domain and range, make a factor of it. We can say x into x minus 24 is less than 0. Yes, you can say why I changed this inequality. Let's see. Here when you substitute this, 12x minus 1 by 2x square is bigger than 0. So you can, not here, sorry, here it is bigger than 0 because it is positive. So when you multiply the expression with a negative sign to make this x square positive, let's see, I'm doing the steps for you. So multiply negative, it become positive 1 by 2x square minus 12x. It means I'm shifting these to other sides, so this will be become less than 0. As I'm, the property says if a is bigger than b, so it means b is smaller than a. Or if you have minus like property with negative property, a is bigger than b, so minus a is less than negative b. If you multiply with inequality with any negative number or with you can divide with a negative number, then do change the face of inequality. This was a property, okay. Whenever we multiply the inequality with a negative number, we always change its face. So here 2 is going to multiply throughout x square minus 24x is less than 0, so x can be taken as common, so x minus 24 that I wrote before, okay. I hope you got it. Why I change the face of the inequality? To make the x square term positive, so I need to multiply the entire lines with the negative sign, so I change the inequality. So hence here I get x for critical solution, for critical solution x will be 0 and x will be 24. So my domain of the function is 0 less than equal to, it's lying between this one. Like if you draw the figure, so here 0 and 24. Now for range, area as it was given to be 12x minus 1 by 2x square, so we can say area is equal to minus 1 by 2. If I take it, it's equal to x square minus 24x. Now by completing square method, by completing square method, minus 1 by 2 as it is, x square minus 24x, half of 24 is 12, so 12 square minus 12 square, so a will be minus 1 by 2 x minus 12 whole square plus minus 1 plus 72. After simplifying we get this one. Okay, so the turning point of this function are 12 and 72. This implies that is like the same h and k. This implies range of the function is y is smaller than or equal to 72. How? Let's see. Because here you have a negative in the function area, so it will be concave down, concave up, sorry, like this. The figure will be like this. So if it is 72 here somewhere, and here it is 12, so turning point of the curve becomes 12 and 72. Fine. So this was the final answer, how to find the domain and range after proving this area. Okay, let's proceed for the next question. Question number 8. Okay, here question number 8. Here the questions is to be asked in a square, A B C D. The vertices are 1 1 and 7 5, and it was A and C. We have to find number 1, the equation of diagonals BD. Number 2, we have to find the coordinates of B and D. And finally, the equation of circle where A, B, C, D inscribed. Okay. First of all, you are given a square. Say A, B, C and D, all sides equal. We are given the coordinates of A and C, that was 7 and 5. And BD we are looking for. Suppose B is here, AB. We know that equation of the diagonal BD, we are looking for this diagonal. Okay, and what will be the gradient of this A and C diagonal? This diagonal AC, we know that diagonal the gradient of AC will be the change in y, ratio of change in y to change in x. That will be 4 by 6, that is 2 by 3. And by property of square, the diagonals bisect each other at the mid here, M point. So as they are perpendicular, so it means gradient of BD will be the negative reciprocal of gradient of AC. So it becomes minus 3 by 2. So midpoint of AC, that is M. We can find the midpoint rule, that is 7 plus 1 by 2 and 5 plus 1 by 2, that gives me 4 and 3. Between this point M is 4 and 3. Therefore, as BD is lying, M is lying at BD, therefore equation of BD, the part 1, at MBD, that was minus 3 by 2, and passing through the point M, that was 4 and 3, is, then we know that y equal to mx plus c. So m is here minus 3 by 2, x plus c. For c we can replace this point, so 3 is y minus 3 by 2 times 4. 3 is equal to minus 6 plus c, so c becomes 9. Therefore, equation of BD is y equal to minus 3 by 2x plus 9. This is the first equation. Second part of the question, the examiner asks us to find the coordinates of B and D. B and D coordinates we are looking for. So as you can see from the figure, the point, if we suppose the coordinates of B are AB, that is passing from the line BD. So we can say, as from part 1 we have equation of BD, that is the minus 3 by 2x plus 9. So at point B, that was AB, so we get minus 3 by 2a plus 9. Or you can multiply 2 through to make a straight equation, 2b minus 3a plus 18. Or we can write 3a plus 2b equal to 18. This is, say, equation number 1. And secondly, you can see the gradient of BC is perpendicular to the gradient of AB. Yeah, so we'll find the both gradient as gradient of BC times gradient of AB is equal to -1, because here it was C, B, and here it was A. So you can see this gradient and this gradient are perpendicular to each other. So we can say that their product of their gradient should be -1. So let's see the BC. It becomes B minus 5 over A minus 7. And gradient of AB, that is B minus 1 over A minus 1 equal to -1. Simplify this. We will multiply numerator with numerator and denominator with denominator first. B square minus 6b plus 5. Here a square minus 8a plus 7 equal to -1. By 1 do the cross multiplication. We get a square plus b square minus 8a minus 6b plus 12 equal to 0. This is the final cross multiplication. After simplifying, we will get this equation number 2. Now you need to solve these two simultaneously by solving 1 and 2 simultaneously. We will get here, you guys are well aware how to solve this. make any variable selector formula, put it here, and after getting a quadratic equation, simplify this, you will get a equal to 2 and a 6. We'll get two values of a. That gives me two values of b. When a is 2, then b is 6. When a is 6, then b is 0. As we are looking for the two coordinates of c and d, therefore we can say c is if 2 and 6, then d will be 6 and 0. So this is the answer for the second part. In the third part of the question, he asked to find the equation of circle where ABCD is inscribed. Inscribed means inside it. So here I need to make this circle like this. Let me erase the final thing. Oh. This. Now we are going to find the equation of circle where ABCD is inscribed. ABCD square is inscribed inside it. Now we have all the coordinates with us. So when we inscribe this one, keep one thing clear, this M becomes the center of the circle, and MC or MD or MA or MB is called a radius. This become R radius. These are R radius of the circle. So we know that equation of circle with center AB, here we have M, that is 4 3, and radius say R, that is suppose AC, is x minus a whole square plus y minus b whole square is equal to R square. This is the rule, the formula, where AB are the center of the circle and R is the radius, that is AC or anything. So if we can find the A and C, that is 7 minus 1 squared and 5 minus 1. Okay, 7 minus 1 whole square plus 5 minus 1 whole square. I apply the length formula, 36 plus 16, that goes to be 52 square root. So do replace the values here. So finally my answer, the equation of circle, finally required equation becomes x minus a whole square plus y minus, because a b are here, minus b whole square is equal to R square. So x minus 4 whole square plus y minus 3 whole square is equal to 52. Either you can simply expand this by applying the identities to make more simplification. So this is the final answer of the question. I hope it is clear. Now the next question is about the function. Question number 9. Question number 9. You are given f of x 2x minus 1 and g of x 2x square minus x minus 1. We have to find the composition function f g of x. How can we? You know, f g of x simply in routine practice, function g should be in f. So f g of x will be, do replace all x in function f with value of g of x, we get 2 times 2x square minus x minus 1 minus 1. Simplify this, 4x square minus 2x and minus 3. This is the first part. In second part, we have to find the inverse function, gf inverse of x, meaning this answer of the part 1, we have to get the inverse of this. So we need to solve it by completing square method. This is a gf of f, not this part 1. This was f g of x, this is gf of x. So first make a function f in g. So g f of x will be, it means f of x function must be replaced in g. Any 2x minus 1 should be here. We get 2 into 2x minus 1 square minus 2x minus 1 minus 1. Simplify it, 4x square minus 4x plus 1, 2x plus 1 minus 1. So finally, the function g f of x, we will get 8x square minus 10x plus 2. This is the new function gf of x. Now we have to find the inverse of this function to get the answer. So the same procedure, it's a quadratic, so we need to make x subject a formula. So for the quadratic function, we always make the completing square before we get the subject. So by let y equal to 8x square minus 10x plus 2. So by completing square, y equal to, take 8 common, x square minus 10 by 8 becomes 5 by 4, and let the 2 be out. So half of 5 by 4 is 5 by 8. So square of this should be added and subtracted like this, plus 5 by 8 square minus 5 by 8 square to make the balance, and 2. We will get 8 into x minus 5 by 4 whole square, and after simplifying we will get it minus 9 by 8. So bring it here, y plus 9 by 8 equal to 8 into square. So divide by 8 either side, we get 8y plus 9 by 64 is equal to x minus 5 by 4 whole square. So taking square root on both sides, 8y plus 9 by 64 square root plus minus x minus 5 by 4. Bring it here. So 5 by 4 plus minus 8y plus 9 by 64 equal to x. So x will be 5 by 4 plus minus 8y plus 9 by, and square root of 64 is 8. I will write 8 here. This is not, this is 4, it is 64 square root is 8. Okay, furthermore we can write x is equal to 5 plus minus 8y plus 9 whole divided by 8. This is the inverse function. So we can say gf inverse of x is 5 plus minus 8y plus 9. Y will replace in x over 8. This is the final answer of the question to be asked. Finally, in the third part of the question, he asks us find if possible, solve f g of x equal to 3x square plus 1. 3x square plus 1. So f g of x, we already calculated it. F g of x in the first part, that was 4x square minus 2x square minus 2x minus 3 and equal to 3x square plus 1. Simplify everything, bring here to simplify. 4x square minus 3x square minus 2x minus 3 minus 1 equal to 0. So x square minus 5x minus 1 equal to 0. We will get this thing, right? Now we need to solve this either by converting square or any method. You can solve this. So it's minus 2x x square is minus 2x, right, and minus 4. Right, by converting square we can solve x minus 1 square is equal to 5. So x minus 1 square root is equal to plus minus 5 square root. So x minus 1 equal to plus minus square root 5. 1 plus minus square root 5. This is the answer, the required answer. I hope everything is clear. Yes guys, now proceed for the question number 10, the second last of the question. This is about trigonometry. Question number 10. Questions 6, 7 and 8 were the question where student was little sticky about the concepts, so you need to put little hard work to revise those concepts. So here the first part of this is stated that prove that 1 plus 2 sine of x times cos of x over cos square x minus sine square x equal to 1 plus tan x over 1 minus tan x. So we start from the left hand side. 1 plus 2 sine x times cos of x is cos square x minus sine square x. We know the identities that sine square x plus cos square x equal to 1. So it means 1 is equal to cos square plus sine square. So I can write it in place of this one. I will write cos square of x plus sine square of x, because this is equal to 1. And next is plus 2 sine x into cos x. And in denominator we know that the rule, the identity, the algebraic identity a square minus b square will be 1 time plus and 1 time minus. I will apply this. Cos x plus sine x, cos x minus sine x. In the numerator, if you can focus, it is the rule of a square plus b square plus 2ab, that is a plus b whole square. Yes, so we can apply the identity. It can be cos x plus sine x whole square, and divisor, let it be in this form. Here you can see the 1 will be cancelled with it. We get cos x plus sine of x, cos x minus sine of x. as we have to prove this equal in term of tan, and we know tan of x is the ratio of sine to cosine. So if I divided each term with cos of x, let's see what it will come. Divided by cos of x, sin x over cos of x, cos x over cos of x, cos of x. Here it goes. So it will be 1 plus tan of x over 1 minus tan of x. That is the right hand side, hence proved. This was the question. The student stuck at this rule, the basic rule of trigonometry, that sine square plus cos square is equal to 1. So it means whenever the sine and cos comes to be in square form and they're going to be plus each other, then it's always 1, and we proved this in class how it comes. So I hope it is clear. If you guys want to revise the proof how it this sine square plus cos square is equal to 1, then tell me, I will refresh it. Okay, B part of the same question was, we need to solve 3 tan square of x minus 2 tan it of x minus 5 equal to 0, where the angle is lying between first two quadrants, 0 to pi. Okay, here let y equal to tan of x. So it means y square will be tan square of x. Replace here, we get 3y square minus 2y minus 5 equal to 0. Okay guys, here we get the quadratic equation in term of y, so you can apply the quadratic formula, factors, and any approach to solve this. And finally I'm going to apply the midterm break rule here. So after that I will get I will get y plus 1 times 3y minus 5. I applied the midterm break rule, so y is equal to minus 1 and y equal to 5 by 3. Two values of y. So now do replace the y with what we started from. It is tan of x, here negative 1, so less than 0. It means it is falling in second quadrant as a concept of quadrant, and when it is the value tan of x is 5 by 3 is positive, so it falls in the first quadrant. We can't proceed more than this because it's given that your result angle should fall between the first and the second quadrant, 0 till pi, not more than this one, not in third quadrant, not in fourth quadrant. So here when we solve this, tan of x is equal to 1, x goes to be tan inverse of 1, that I will get pi by 4. So as it falls in the second quadrant is we have pi minus theta. If in the first quadrant we have theta, so it is pi minus theta radian. So I will write my answer, x is equal to pi minus pi by 4 will give me 3 pi by 4. This is one of my answer in radian, RAD. Similarly here, as is first quadrant, it will be as it is tan inverse of 5 by 3. I will get in radian. So do replace because the angle is in radian, so you guys need to change the mode of your calculator in radian to get this perfection in answer. So x goes to 1.03, that's again in radian. Okay, this is the end of question number 10. The final question is about, yes, here I'm going to start it. The question number 11. It was again about the function. Find a domain of this. Find the domain of 2x square minus x minus 3. Okay, the first part was this, and how domain of this is, you know, square root function, so it must be in the square root function. We know that function must be greater than or equal to 0, because with the negative it doesn't exist for a real value. So we start from here, 2x square minus x minus 3 greater than or equal to 0. So by midterm break rule I got this one. So the critical solution for I will get 2x minus 3 x plus 1 equal to 0. So x will give me 3 by 2 and x will be, these are two roots of this expression. So my final values of domain will be x is less than equal to -1 and it is bigger than equal to 3 by 2 or 1.5. This is the first answer. The second part of the same question, 11, we have to solve. This is 5 marks question. Solve 2x raised to power 5 minus x raised to power 5 by 2 minus 3 equal to 0. So it's a simple question, and the most of the students did it very comfortably. Yeah, let's make a quadratic one by substituting another variable, x power 5 by 2 equal to y. So y square will be x power 5. So we get 2y square minus y minus 3 equal to 0. Again apply the midterm break rule. We will get y, to answer of y, that is, or you can apply the quadratic formula, doesn't affect it. Any approach which is easy for you. We get these two values of y. Now resubstitute this here from where we started up. So x power 5 by 2 one time equal to -1, and here x power 5 by 2 is equal to 3 by 2. So in order to remove this, take reciprocal power of this one on either side. So I can say x is equal to minus here 2 by 5, and here x will be 3 by 2 power 2 by 5. So on the calculator I will get this 1, and here I will get 1.176. Use the calculator properly and you will get these two answers. So this is the end of chapter or end of paper 9709 paper midterm from so this is the end. Okay guys, see you next video for the next paper. Have a good time. Bye.